Hey guys, welcome back. In this video, we'll be talking about some examples from Lamis theorem. And first of all, we'll just have a brief idea of what Lamis theorem is. So, if the body is in equilibrium under the action of only three coplanar no concurrent forces, then Lamis theorem can be used. So here, if a body is in equilibrium under action of three forces, then each force is proportional to the sine of angle between them. So here we have a force P, and the opposite angle of that force is alpha. So Lamis theorem is just stating that P by sine alpha will be constant. That means even if you take the value of Q by sine beta or sine by R by sine gamma, it will all be the same value. So from this we can uh, solve a lot of problems instead of resolving it into x and y axis. In this manner we can solve the problems much more faster. So this is the first question here regarding this Lamis theorem. A sphere of weight 100 Newton is tied to a smooth wall by a string as shown in figure. We need to find the tension T in the string and the reaction R of the wall. So here, please don't look at this now. Just concentrate on this part. Okay. So when you look at this, what you understand here is that there is a cylinder which is tied to the wall with a wire, and it is supported by the wall. So there are some forces here acting. So what we will do at the first part is that the step one will be to draw the free body diagram. So we will be drawing the free body diagram. So here we have the cylinder. Here we have the cylinder, and there is a W force which is acting downwards. Then there will be a tension force, and there will be a reaction force. Okay, so these are the forces that are acting on that cylinder. Now what we will do here is that now we will draw the force diagram. So what is a force diagram is force diagram is nothing but if we remove the object also and just consider the forces, then that is called the force diagram. So this is the force diagram, and it is just it only shows the reactions and the tensions and the weight acting on that body, and considering the object to be a single point. Okay, so here we have the reaction force in this side and tension force on the other side and W force on the downwards direction. So we are also given this angle here. Actually this angle is somewhere around I don't know, but there should be some angle. So of course this angle will be 90 degree, that we know that. Then here we have 105 degree, and here we have 165 degree. So Lamis theorem states that the force divided by the sine of the angle of the opposite side will be a constant. So R by sine 165 will be equal to W by sine 105, which will be equal to T by sine 90. So this is what we get. We know that sine 90 is equal to 1, so we'll be getting T is equal to W by sine 105. We know the value of sine 105 also. From that we'll get W is equal to T into sine 105. So we'll get the value of W, T and R. Okay. So all those burden of doing resolving and has been rapidly decreased if you are using this Lamis theorem. Now let us move to the second problem. In this problem you will have to do this. So The second problem states that determine the horizontal force P to be applied to a block of weight 1500 Newton to hold it in position on a smooth inclined plane AB, which makes an angle 30 degree with the horizontal, okay. So we need to determine the horizontal force P. Okay, so pause this video, understand, just look at this diagram and brainstorm, understand, and draw a diagram. Don't look at this diagram, or there won't be any use. Okay, so I hope you have drawn the free body diagram, and you must have also got the answer also, because it's nothing but if you draw the free body diagram of this box, there will be a reaction force which will be like this in this direction. It will be like this, and there will be a P force like this, and also don't forget this weight W like this. Okay, so if we combine this, we'll be getting something like this, and if you remove this box and consider this as a point, then we'll get the force diagram. And about these angles, if you take this angle and just to keep it in this manner, okay, if you take this in this manner, we know that this angle will be 30 degree, because I have already told you that alpha will be equal to theta, so this will be equal to 120 degree, and this will be 90 degree, so this one will be 150 degree. From that you will get P by sine 150 is equal to W by sine 120 is equal to R by sine 90, and if you solve this, we'll get P is equal to 866 Newton. Okay, now let us move to the example number 3. A rope AB 4.5 meter long is connected at 2 points. So rope AB is connected at 2 points here in the same level, 4 meter apart. So this length is 4 meter. I don't know this. A load of 1500 Newton is supported from a point C on the rope 1.5 meter from A. So this is our rope which is acting downwards like this, and as shown in figure, what load connected at point D on the rope 1 meter from the from B will be necessary to keep the position CD level. So this is our diagram. So what we need to find here is that we need to find W. We need to find W. So how will we do this? If you carefully look at this diagram, here we don't know the value of alpha. Here we know that it is 2 meter. Here it is x. Here it is 2 minus x. If we add all this, AB is equal to, this part is equal to 4. And this is equal to 1.5. And here we have tension force of 1500 Newton. And this also we don't know. Okay. So this is what it is. And here we need to find a tension force like this. Then there will be a force like from this side, and there will be a force like this, and W is what we need to find. So pause this video, do it yourself, and come back. So you must have completed or you must have got some idea, or you may have be stuck at somewhere. So let us look at it. So we know that AB is equal to 4 meter, AC is equal to 1.5 meter, Then EF and CD is equal to 2 meters, DB is equal to 1 meter, and AE is equal to x, FB is equal to 2 minus x. We know that this is a right angle triangle. This triangle AEC is a right angle triangle. Then we know that this let us consider this to be y. Okay, then x square plus y square will be equal to 1.5 squared. Yes, you know till then. Then we know that this x square can also be and here in triangle FBD also is a right angle triangle. Then we know that 2 minus x whole square plus y square is equal to 1. And if we solve these two equations, we will get the value of x, which is 1.1325. If we get the value of 1.1325, we know that cos alpha is equal to x by 1.5. So it will be cos alpha is equal to 1.3125 divided by 1.5. So alpha will be equal to cos inverse of 1.3125 divided by 1.5, which is somewhere around 61 degrees. Now we know that this is the T1 tension, and here we have the T2, and here we have W. So this angle will surely will be greater than 90, and it is 90 plus 151.1 degree. So it is 151.04 degree, and here it is 90 degree, and so this will be equal to 118.95. Now if we solve these equations, we will get the value of T1 and T2. Okay, now we have got the values of T1 and T2. Now we will move to the second one. Here we need to find the value of W. Similarly, we will do for triangle AEC. Cos alpha is equal to this 1.3125 divided by 1.5, and we'll get some values like this, and BFT also will get some value. And if you do that, and if you do this problem like this, we will be having the angle here also, and just do this Lamis theorem, and you will get the value of W, then we'll get the value of T3, and it's just that. It's very simple. Now let us move to assignment question number 4. We are having assignment question number 4, 5, 6, 7. So there are 7 problems. So I will do one thing. As these all of these problems are a bit lengthy, so I think I'll just stop here. We'll do these problems in the next one, so please do watch this next problem because these are very important and it will fetch you marks in your semester end exam also, and also in this module 1 exam, so please consider it now. So thank you for watching. I'll see you in the next one. Thank you.